Hi, good day. I'm Felix Kema from Nigeria. I'm here to make a PPT presentation on data science life cycle. So here is an introduction to data science life cycle. Data science life cycle is a systematic process that data scientists use in extracting values and insights from data in order to solve problems for businesses. It has to do with the different methods at which data scientists employ in tackling data analytic problems. These different methods involve different programming, mathematical, statistical, and business-oriented methods employed in solving data science problems. These steps involve the use of different tools in achieving its aims. These tools involve both statistical, mathematical, programming, and database management tools. These tools are deployed at different stages of data science in achieving the aim of a project. Data science, as we know, as it's science that deals with data, makes use of different methodology in achieving its aims, and these aims are being used by different tools in trying to solve a specific statement problem given by the client for the aim of the project. So when it comes to data science life cycle, we are trying to look at those different steps, methodologies at which we can achieve a data science project. These methods are being employed at different stages of data science with different tools and different technicalities. These tools involve Excel, SQL, Tableau, Power BI, MATLAB, Python, R, SAS, etc. And these tools are deployed at different stages of data science in solving and analyzing a problem. These tools, in conjunction with each data science life cycle, are deployed in tackling and solving a particular statement problem in the project. At each of these levels, a tool is deployed in achieving its aim. Tool like Python, which is a multi-purpose programming language, can on its own be able to undergo all the stages of data science life cycle. We all know that Python is a multi-purpose language, and with the functionalities and different libraries in Python, we can use Python to run a full data science project. Just as we also have in SQL and Tableau and Power BI and Excel, we know that in order to, if you don't want to use Python and you want to make use of Power BI and Excel, you have to use Excel and SQL for your data analysis and collection, and now make use of your Tableau and your Power BI for your visualization. But when it comes to Python, Python is a multi-purpose programming language which can run all the stages of data science life cycle. In this project, we are going to concentrate on Python and MySQL as two major tools which will be used in explaining data science lifecycle. Other tools will be referenced where necessary. Codes and queries will be written. Now, let's enter the stages and steps of data science lifecycle. The data science lifecycle involves different stages and steps. They are as follows: 1. Problem definition. 2. Data collection. 3. Data cleaning and preparation. 4. Exploratory data analysis, that is EDA. 5. Feature engineering. 6. Modeling. 7. Model evaluation. 8. Deployment. 9. Monitoring and maintenance. We shall look at each of these stages step by step. 1. Problem definition. Problem definition is the process of clearly identifying the statement problem in a data science project. It involves proper definition of the objectives, scope, and constraints of a project. It is the first step in every data science project, and it helps to ensure that the project stays on track. In order to achieve this, there are many steps to be carried which will help in proper definition of the statement. When a problem is given to a data scientist, when a client brings a project for the data scientist to execute, this project always have some statement problem which is required by the data scientist to work on. Now, the ability to be able to know and to identify the right problems and the right steps to tackle these problems are what we are talking about in problem definition. One of the steps in achieving this is by being clear. Every data science project needs a well-defined problem statement, and this problem statement is always stated by the client who gives the project. Well stated by the client, pointing out and stating the major objectives to be achieved. The second one is breaking down the problem. Once you have noticed the problem and you have understood the problem involved, it is necessary that the problems has been broken down into different steps such that each of these steps have a particular technicality and tool in solving it. When actually understanding the problem statement of a project, it's necessary the problem statements are broken down into stages in order to fully understand and comprehend the major objectives of the project. The third way of trying to get a problem definition is by involving multiple people, and this is carried out by trying to involve other data scientists or trying to involve other business oriented professionals who are good in the particular project that has been given to you, people who have knowledge, who have done survey and understand the the scope of the project. So you try to involve these people in the project you are trying to do so that you have a good problem definition about the statement problem given to you. And the last one is to establish success criteria. Success criteria has to do with the process at which you try to set out aims and objectives of how you want your project to be carried out. In order to achieve a project, a data scientist needs to set out successful outlines necessary to solve and tackle the statement problems at each stage of data science. These criteria helps to give a guide in the development of the project and its analysis. Without a successful criteria, it will be very difficult for a data scientist to carry out a successful project, because this tells us what we do at each point of the project steps. Then moving down to the second life cycle of data science is what we call data collection. Data collection is the process of gathering and evaluating information to answer questions, to solve problems and make decisions. It has to do with research methodologies which involves manual approach like interviews, surveys and fieldwork. Data collection is simply an automatic way at which we try to have a collection of a data set. So there are many ways of data collection. We have the manual way of data collection, which has to do with going out for interviews and surveys or even fieldwork, where you get data from people as you meet them one-on-one. Then we have an automatic way of trying to get data sets from different data sources. Like if you go on Kaggle, you get different set of data sets. If you go on machine learning repository, or even some client provide data set. So the ability of the process of collecting this data set into the IDE which we are using for our project execution is part of what we mean by data collection. And using Python as a case study, data can be collected from a data set with the code below. Before collecting the data, we import pandas. Pandas is a library in Python which helps in manipulating data. So we import pandas as PD. We set a variable and df equals to pd.readcsv dataset. So if the name of the dataset, for example, if the name is iris.csv, so we now read it to be df equals to pd.readcsv iris.csv. Then you use the head function to run and you get the first 5 columns of that very particular data set. Now the code we just look at helps in collecting data from a data set. This is achieved by first importing the pandas library, after which the head variable is created and the data is collected using the pandas.read function. By running the df.head, the data is depicted in the form of database as in an Excel format. So what pandas tries to do for us, pandas as a library tries to represent the data acting like an Excel. So it tries to create an Excel, a kind of a database that looks like an Excel format. Data collection is an important aspect of data science lifecycle as it deals with data that contains the information necessary for the project analysis and development. It's very crucial for data science. Data collection, in fact, is one of the most important aspects of data because without the data being collected, there is no project can be successful because it's the data that is collected that we worked on. So without collecting the data, you can't do anything. So this makes this very particular step to be very important. Then the third stage of the life cycle of data science is data cleaning and preparation. And before I continue with this stage, I want to let you know that this is one of the most important stages of data science life cycle, data cleaning. Or you don't call it data cleaning, you call it data wrangling. This stage is very important. This is the stage where we clean the data, we find out the missing values in the data, we replace our missing values with either their mean or we dropped the missing values, we find all our null values, we look at our data types. Is there any data types that is not of its right type? We try to change the data types. This is where we try to standardize the data. This is where we try to check the names of different elements in our columns and we try to rename some of them. So this is very crucial when it comes to data science. Now let's begin. Data cleaning can also be known as data wrangling. It is the process of cleaning data by removing duplicates, standardizing numerical values, converting data types, filtering the data, structuring the data, and also renaming some columns and elements in the dataset. In order to remove duplicates from a data, the code below is used, df.dropped duplicate. This set of code helps to drop any duplicates in the data. And to check the presence of duplicates, we use the df.duplicated. To check for the presence of null values, we use the df.isNull. To check for the presence of NA values, we use the f.isNA. To drop NA values, we use the f.droppedNA. In order to check the data types, we use the f.dtypes. To check for number of columns, we use the f.columns. To check the shape of the data, we use the f.shape. Not all NA values are dropped. In case of numerical elements, the mean of such values can be used in replacing the null data. Also, during this stage, the mathematical and the statistical analysis of the data is checked by using the df.describe function. The df.describe function is a set of code that tries to give us a mathematical analysis of the data, where we try to get the mean of the data, the maximum number, the minimum number, the standard deviation of the data, and minimum numerical information in the data. Also, we also use the df.info, which also tries to give us a computational information about the data. During data cleaning, the data types of the columns and data are checked. It is very necessary because most data might be in a string format, and in the database entry, it will be showcasing as an int. Also, an integer set of values might be showing as in an object format. Hence, it's very important to check and make changes to these data types where necessary. Also, numerical values are of different range and scale, as a number can be ranging from between 1 to 20 in a particular column, and in another column, values will be ranging between 10,000 to 100,000. During data visualization and model development, If these data are not standardized, it will lead to a poor performing model or a wrong dashboard. Hence, it is important and necessary to standardize all numerical values for easy plotting and visualization. In order to do this, we make use of the standard scalar object. The standard scalar object helps us to standardize the data to a range that is suitable for plotting and good for model development. In general, data wrangling is very crucial in data science as it's the stage that much attention and work is done. This stage requires much concentration, skill, and expertise in knowing the right data to keep, to add additional data to add, and also many more things to do. This is where good informations are gotten from the data. Now moving to the next data science life cycle is where we have our EDA, exploratory data analysis. This is an approach of analyzing data to summarize their main characteristics, often using statistical, graphics, and other visualization tools. This is where we make use of dashboard. We create some dashboard and we try to make some graphical or pictorial representation of it. This dashboard tries to create a graphical representation of the mathematical or statistical values, the statistical information that we have in our data. They try to give us a pictorial view of it mathematically. So we make use of different visualization tools like Tableau, Power BI, Python, SAS, and so many more in visualizing this. Now, using Python as a case study, data are visualized with the help of the Matplotlib and Seaborn library. These libraries helps in visualizing data in a graphical form such that it depicts same as Tableau or Power BI. In the Matplotlib and Seaborn library, there exist different visualization functionalities which helps in giving different visualization. Among these functionalities in the Matplotlib and Seaborn library, we see the bar chart, the pie chart, the histogram, the bubble chart, the scatter plot, the pair plot, and many more. These different plots are used for different visualizations. Some are used for visualizing categorical variables, while some are used to show the distribution between variables. Some of the plot shows relationship between two or more variables. With the help of EDA, many informations are derived as they show the correlation between variables. They show the linear relationship and how variables depend on each other. With the help of EDA, a good knowledge of machine learning or model development is acquired as the visualizations gives more insight about the data. For example, a scatter plot showing a linear relationship between two variables. So if you are having a linear relationship between variables, let's say you are having a linear relationship between price of the Bitcoin and the rate at which people are buying Bitcoin. So if you have the price to be at your X coordinate and you have the rate of buying to be at your Y coordinate, so when you plot it with a scatter plot and there exists a linear relationship where they try to have a kind of straight line, a linear relationship. So with such a relationship showing in your visualization, that will be able to give you a kind of an idea when you want to build your machine learning model. So with that very particular visualization, common sense will tell you that you are going to make use of a linear regression model in trying to build your machine learning model because the visualization have already given you a good information about it. So EDA is one aspect of data science that is very important that gives us a lot of information about what is happening with our data and what to do with the data when it comes to building model. It is used to validate data, generate hypotheses, and identify trends. It helps in visualizing data in an X and Y coordinate system using the X and Y axis and its reference. It serves as an important aspect of data science as it gives the client a quick information about the analysis made so far in the project. It's like the mirror of the entire project. After finishing and doing everything in your project, is you will still visualize your informations, and it's the visualization you have gotten from your information that you use and create it as a dashboard which you present to your clients. So this EDA is very important when it comes to data science life cycle. Then move to the fifth one, feature engineering. Feature engineering comes as a result of after proper data cleaning and data visualization. When you try to furthermore process your informations and trying to build some model, that's when you are going into machine learning. Before you go into machine learning, you have to do some feature engineering work. And this feature engineering work is a technique that involves manipulating data to improve machine learning model training. It's a process that involves domain expertise and human intelligence, aims towards making a good model for development and training. When feature engineering is well carried out and accurate, its accuracy can give a good model ready for training and development. Now, let's look at different types of feature engineering, different processes that we can use in achieving a good feature engineering process. One is what we call feature creation. In feature creation, new data or columns can be created through the process of binning, splitting, facilitated values, and using one-hot encoder. In summary, this process is where we try to look at the data. If you look at the database, like kind of view the data using your df.head, and when you use the df.head and you look at the data, you can see that there are possibilities of creating new columns. So if you are having, for example, you have a data set about people who borrowed loan, people collected loan, and within the data you are seeing their ages, their salary range, the loan they borrowed, and the time they are to pay back. So with a proper knowledge of statistics, you can see that there is need to create another column, and one of the column which is able to be created can be, for example, the difference in their salary with the loan they borrowed. So if you have the difference in salary and the loan they borrowed, you can use that to create another column in the data. So during feature engineering, we try to create new columns. Feature extraction, that is the second one. This has to do with the process of reducing the size and amount of data using dimensionality reduction, like principal component analysis or like your independent component analysis. This is where you try to make use of useful information in the data. Try to reduce the data by getting rid of the ones that are not very important in the analysis, and you try to make use of the most important one for your model building. Then we have a feature selection, that is the third one. This has to do with the process of selecting a subset of selected features that are relevant and minimize the error rate of the model. So if you are to build a model, you must make use, you don't have to make use of all the data. So during feature selection, we only select the information that are very necessary for our development. Then fourth one, we have feature transformation. This is a mathematical process of transforming the data to a suitable range or scale. In feature transformation, you try to make sure that all the data in our project is brought to a particular scale, in the sense that when we try to make our visualization, or when we try to build our model, the model will not have a gap. In fact, the model will perform well because we have been able to scale all the data to a suitable scale. So feature transformation is one aspect of feature engineering that is employed in trying to make sure that our work is accurate. Then the sixth step of data science lifecycle is modeling. Modeling has to do with the process of trying to create algorithms and statistical models to analyze and interpret complex data. So if you are to use Python as a model language, modeling involves different algorithms that are employed and built in providing better insight of data. This method is free machine learning, and it deals with the models in a manner that does not require explicit programming. These models, when well built, learn and perform well, thereby giving accurate results and predictions where necessary. And among these models, we have linear regression, logistics regression, decision tree, random forest, k-means clustering, dimensionality reduction, naive Bayes, and so many more. Modeling is the process where we try to use machine learning, where we apply machine learning in data science. In modeling, we try to create models using algorithms, and these algorithms are listed here, and we try to do it using any of the data science and machine learning types. Either you are using it for supervised learning, unsupervised learning, or reinforcement learning, and we do this with the supervision of any of these algorithms. These different algorithms works on different machine learning approaches. Some are good on supervised learning, some are good in unsupervised learning, while some are good in reinforcement learning. This is the stage where a bit of artificial intelligence and deep learning comes in data science. In this stage, the data are splitted, trained, and predictions are made to get more insight about the data. Different libraries are imported, among which is scikit-learn and TensorFlow. So when trying to build our model using machine learning techniques, we either use scikit-learn or we make use of TensorFlow. For the sake of scikit-learn, we make use of many metrics like linear accuracy, mean squared error, accuracy score, arrow squared error, F1 score, and so many metrics. These metrics are used in evaluating the rate of performance of the model. All these objects helps in giving more insight to our data through the model building. Then the 7 life cycle of data science, a model evaluation. After model development, it is very necessary that the model will be evaluated in order to know the performance of the model on the data. This is done with the use of S1 score, linear accuracy, mean squared error, and lots more. In fact, during model evaluation, we try to make use of the evaluation metrics in trying to rate the performance of the model. This part of data science is very important because it tries to tell us how much the model perform on the data, and this is what gives rise to the 8-1 deployment. Deployment is the process of integrating a machine learning model into a production environment so that it can make predictions on new data. It is a crucial step in machine learning that enables the model to perform and make good predictions. This is so important to data scientists as it turns the mathematical and programming tools and models into a perfect model for a real-world prediction. Now, I want you to remember that when a client gives you a project, the client expects you to make, for example, let me make use of the Bitcoin that I was trying to make. Maybe a client gives you a project that you should work on the prices of Bitcoin in the market and how people are purchasing this Bitcoin. Now, the client expects from you that you should be able to create a model, and this model should be able to predict, make a prediction on how people will be able to be buying Bitcoin in future. So the client is expecting a model that can make predictions on the future sales of Bitcoin. So in this deployment stage, this is where we now try to take the model and try to employ this model and test it on the expectations of the statement problem given by the client. So it's a crucial step in machine learning that enables the model to perform and make good predictions. And this is so important to a data scientist as it turns the mathematical and programming tools and models into a perfect model for a real-world prediction. It involves scalability, data privacy and security, deployment and mode, deployment strategy, deployment platform, cloud infrastructure, where it is many cloud facilities like Azure and many more AWS are used in using it. Deployment can be challenging for data scientists because it's often not considered their core responsibility. However, it's important to showcase your skills by deploying your model and getting feedback from users. Monitoring and maintenance. After the deployment of a model, the model is monitored and maintained. So when the model seems to perform well on the real world problems, it is giving more data reference to. So when you notice that the model you have built has been able to give a good prediction of the sales of Bitcoin, then that means that yes, we can always maintain such a model and always give good functionalities to it. But if the model fails to give a good prediction on the sale of Bitcoin, as you're using for example, then we have to make a remodel of such model and make some re-evaluation of it so that we can have a good performing model suitable for our data statement problem. Summary. In order to achieve a successful data science project, all the stages of data science must be taken into consideration by utilizing all the necessary steps involved in each stage. It is of great help and importance to data scientists as this life cycle serves as a guide and steps in achieving the objectives of data science. It is to be noted that no science project can be achieved without the functionalities of the data science life cycle. Hence, all data scientists are to note, adhere to, and follow the cycle as its path is the record to a successful data science project. Thank you very much for listening to this presentation. You are welcome.